According to the National Electrical Code Section 406.3c4, refrigerators and freezers that are electrically operated in dwelling unit kitchens must be protected by a ground fault circuit interrupter, also known as a GFCI. There is an exception, however: refrigerators or freezers that are part of a built-in cooking unit. NEC Section 406.3c also discusses GFCI protection, explaining that ground fault circuit interrupters, also known as GFCIs, shall be installed for the following receptacles installed within 6 feet of the outside edge of a sink top, or within 6 feet of the inside edge of a bathtub or shower stall in kitchens, bathrooms, garages, and accessory buildings used by the public. Based on these National Electrical Code sections, a refrigerator located within 2 feet of a kitchen sink in a dwelling unit must be protected by a GFCI. This requirement applies to all dwelling units, regardless of the size of the unit. Therefore, the inspector's interpretation is correct. The NEC requires that refrigerators within 6 feet of a kitchen sink be protected by a GFCI. In this case, if a refrigerator is within 2 feet of the sink, this falls within the 6-foot requirement. As a result, a GFCI must be installed to protect the refrigerator in a duplex according to the NEC requirements. GFCIs are important safety devices that protect people from electrical shock. They work by monitoring the amount of current flowing through a circuit. If there is a difference of even a few milliamperes between the amount of current flowing into the circuit and the amount flowing out, the GFCI will trip, cutting off the power to the circuit. This can happen if someone is touching a live wire or if there is a ground fault in the circuit. A ground fault is a situation where current is flowing through an unintended path to ground. This can happen if the insulation on a wire is damaged or if there is a short circuit. Ground faults can be very dangerous because they can cause electrical shock or fire. GFCIs are designed to protect people from these hazards. There are 2 main types of GFCIs: receptacle-type GFCIs and circuit-breaker-type GFCIs. Receptacle-type GFCIs are installed in place of standard electrical outlets. They have a test button and a reset button on the front. Circuit-breaker-type GFCIs are installed in the electrical panel. They protect an entire circuit rather than just a single outlet. When choosing a GFCI, it is important to select one that is rated for the voltage and amperage of the circuit that it will be protecting. It is also important to choose a GFCI that is listed by a qualified testing laboratory such as Underwriters Laboratories or Canadian Standards Association. When installing a GFCI, it is important to follow the manufacturer's instructions carefully. It is also important to test the GFCI regularly to make sure that it is working properly. To test the receptacle-type GFCI, simply press the test button. The GFCI should trip, cutting off the power to the outlet. To reset the GFCI, press the reset button. To test a circuit breaker-type GFCI, you will need to use a GFCI tester. These testers are available at most hardware stores. Simply plug the tester into an outlet in the circuit that is protected by the GFCI. Then press the test button on the tester. The GFCI should trip, cutting off the power to the circuit. To reset the GFCI, flip the circuit breaker to the off position and then back to the on position. If a GFCI trips frequently, there may be a problem with the circuit that it is protecting. In this case, it is important to have the circuit inspected by a qualified electrician. There are a few things to keep in mind when using GFCIs. Firstly, GFCIs will not protect people from electrical shock if they are touching both a live wire and a neutral wire at the same time. Secondly, GFCIs will not protect people from electrical shock if they are touching a live wire and are not grounded. Thirdly, GFCIs will not protect people from electrical shock if the GFCI is not working properly. GFCIs are an important safety device, but they are not a substitute for safe electrical practices. Always use caution when working with electricity. Always turn off the power before working on any electrical circuit. Never touch a live wire. Never work with electricity when you are wet. If you are not comfortable working with electricity, hire a qualified electrician. The NEC is a set of standards for safe electrical installations. It is updated every 3 years. The NEC is not a law, but it is often adopted by state and local governments. This means that electrical installations in those jurisdictions must comply with the NEC. The NEC covers a wide range of electrical topics, including wiring methods, overcurrent protection, grounding, and GFCI protection. The NEC is a complex document, but it is important for anyone who works with electricity to be familiar with it. The NEC is available from the National Fire Protection Association. Here are some additional details about the specific NEC sections mentioned. NEC Section 406.3c4 covers GFCI protection for receptacles installed in dwelling units. This section requires that all receptacles installed within 6 feet of a sink in a kitchen or bathroom must be GFCI protected. This requirement applies to all dwelling units, regardless of the size of the unit. The purpose of this requirement is to protect people from electrical shock. Sinks are often located near water, which is a good conductor of electricity. If someone is touching a live wire and is also touching a sink, they could be electrocuted. GFCIs help to prevent this by cutting off the power to the circuit in the event of a ground fault. NEC Section 406.3c covers GFCI protection for receptacles installed in other locations. This section requires that all receptacles installed in the following locations must be GFCI protected: bathrooms, garages, outdoors, crawl spaces, unfinished basements. The purpose of this requirement is to protect people from electrical shock in these locations. These locations are often damp or wet, which increases the risk of electrical shock. GFCIs help to prevent this by cutting off the power to the circuit in the event of a ground fault. In summary, GFCI protection is an important safety measure that can help to protect people from electrical shock. If you are unsure whether or not a receptacle should be GFCI protected, consult the NEC or a qualified electrician. Let's delve deeper into understanding the nuances of GFCI protection, particularly in the context of kitchens and refrigerators according to the National Electrical Code. We'll explore the reasoning behind these regulations, the practical implications for homeowners and electricians, and some common misconceptions. Firstly, it's essential to recognize that the NEC is a consensus-based code, meaning it's developed through a process involving various stakeholders, including electrical engineers, contractors, manufacturers, and safety experts. The goal is to establish minimum safety standards for electrical installations, ensuring the protection of people and property. The requirement for GFCI protection within 6 feet of a sink stems from the increased risk of electric shock in wet environments. Water is an excellent conductor of electricity, and the presence of a sink increases the likelihood of water coming into contact with electrical appliances or wiring. In the event of a fault, where electricity deviates from its intended path, the water can provide a pathway for current to flow through a person, leading to a potentially fatal shock. A GFCI device is designed to detect even small imbalances in the current flowing through a circuit. If it detects a difference of 5 mA or more, it will trip the circuit, cutting off power within a fraction of a second, thus preventing a dangerous shock. While the 6-foot rule might seem arbitrary, it's based on practical considerations. It represents a reasonable distance within which a person might be in contact with both a sink and an electrical appliance. This distance is intended to cover a typical reach or accidental spillage. Now, let's focus specifically on refrigerators. The NEC mandates GFCI protection for refrigerators in dwelling unit kitchens, even if they are not within 6 feet of a sink. This requirement recognizes that refrigerators are often used in close proximity to water sources and that they can be subject to moisture and condensation. Additionally, refrigerators can develop internal faults over time, potentially leading to a ground fault condition. The exception for built-in refrigerators is based on the assumption that these appliances are designed and installed in a way that minimizes the risk of electrical shock. Built-in refrigerators typically have better insulation and grounding than freestanding models. However, it's crucial to ensure that even built-in refrigerators are properly installed and maintained to maintain their safety. It's important to note that GFCI protection is not a substitute for proper grounding. Grounding provides a low-resistance path for fault current to flow back to the source, helping to prevent voltage buildup and reduce the risk of shock. GFCI protection, on the other hand, is designed to detect and interrupt ground faults, regardless of whether the circuit is properly grounded. In many cases, both grounding and GFCI protection are required to provide comprehensive electrical safety. When installing GFCI protection for a refrigerator, it's important to consider the specific requirements of the NEC and any local amendments. The NEC specifies the types of receptacles that are permitted to be used with GFCI protection and the methods for wiring the GFCI device. It's also crucial to test the GFCI device regularly to ensure that it is functioning properly. Most GFCI receptacles have a test button that can be used to verify that the device is tripping correctly. It's recommended to test GFCI devices at least once a month. If a GFCI device trips frequently, it could indicate a problem with the circuit or the appliance that it is protecting. In this case, it's important to investigate the cause of the tripping and take corrective action. It's also worth noting that GFCI protection can sometimes cause nuisance tripping, particularly with older appliances or appliances that have motors. Nuisance tripping occurs when the GFCI device trips even though there is no actual ground fault. This can be caused by normal leakage current from the appliance or by electromagnetic interference. If nuisance tripping is a problem, there are a few things that can be done to mitigate it. Firstly, try replacing the GFCI device with a newer model that is less sensitive to leakage current. Secondly, try using a line filter to reduce electromagnetic interference. Thirdly, try moving the appliance to a different circuit. If none of these solutions work, it may be necessary to consult with an electrician. Finally, it's important to be aware of the limitations of GFCI protection. GFCI devices are designed to protect people from electric shock, but they will not prevent all electrical accidents. It's still important to follow safe electrical practices, such as avoiding contact with live wires and using caution when working with water near electrical appliances. The National Electrical Code section regarding GFCI protection is not just a set of rules, it's a comprehensive framework designed to minimize the risk of electrical hazards in various environments. Understanding the underlying principles and practical implications of these regulations is crucial for both homeowners and electrical professionals. One of the key aspects to consider is the concept of dwelling units. The NEC defines a dwelling unit as a single unit providing complete and independent living facilities for one or more persons, including permanent provisions for living, sleeping, cooking, and sanitation. This definition is important because the GFCI requirements often differ between dwelling units and other types of occupancies, such as commercial buildings or industrial facilities. The rationale behind stricter GFCI requirements in dwelling units is that these environments are typically occupied by individuals who may not have specialized knowledge of electrical safety. Therefore, additional safety measures are necessary to protect them from potential hazards. In the context of kitchens, the NEC mandates GFCI protection for receptacles serving countertop areas. This requirement is intended to address the risk of electric shock associated with the use of portable appliances such as toasters, blenders, and coffee makers near water sources. Countertop receptacles are often located within easy reach of sinks, increasing the likelihood of contact with water. Furthermore, the NEC requires GFCI protection for receptacles within 6 feet of the outside edge of a sink in kitchens, bathrooms, and other similar locations. This 6-foot rule is based on the principle of minimizing the potential for contact with energized parts while in proximity to water. The distance is considered a reasonable reach for most individuals, and it provides a buffer zone to reduce the risk of accidental contact. It is important to note that the 6-foot rule applies to all receptacles, regardless of whether they are intended to serve specific appliances. This means that even a receptacle that is only used for occasional charging of a mobile phone must be GFCI protected if it is located within 6 feet of a sink. The NEC also addresses the issue of GFCI protection for specific appliances, such as dishwashers and refrigerators. While dishwashers are typically required to be GFCI protected, the requirements for refrigerators can be more nuanced. As previously mentioned, the NEC mandates GFCI protection for refrigerators and dwelling unit kitchens, with an exception for built-in refrigerators. The reasoning behind this exception is that built-in refrigerators are generally considered to be more permanently installed and less likely to be moved or tampered with. However, it is crucial to ensure that even built-in refrigerators are properly grounded and that their electrical connections are protected from moisture and physical damage. In some cases, local codes or amendments may impose stricter GFCI requirements than the NEC. It is essential to consult with local electrical inspectors or qualified electricians to determine the specific requirements in a given jurisdiction. In addition to the specific requirements for kitchens and appliances, the NEC also provides general guidelines for GFCI protection in other areas of dwelling units. For example, GFCI protection is typically required for receptacles in bathrooms, garages, outdoors, and unfinished basements. These locations are considered to be more prone to moisture and ground faults, increasing the risk of electric shock. When installing GFCI protection, it is important to follow the manufacturer's instructions carefully and to use only listed or certified devices. GFCI devices are available in various types, including receptacle type, circuit breaker type, and portable GFCI adapters. The choice of GFCI device will depend on the specific application and the existing wiring configuration. Receptacle type GFCIs are designed to replace standard receptacles and provide GFCI protection at the point of use. Circuit breaker type GFCIs are installed in the electrical panel and provide GFCI protection for an entire circuit. Portable GFCI adapters are convenient for temporary use and can be plugged into existing receptacles to provide GFCI protection for portable appliances. Regardless of the type of GFCI device used, it is essential to test it regularly to ensure that it is functioning properly. Most GFCI devices have a test button that can be used to verify that the device is tripping correctly. It is recommended to test GFCI devices at least once a month. If a GFCI device fails to trip when the test button is pressed, it should be replaced immediately. In addition to testing GFCI devices, it is also important to inspect electrical wiring and appliances regularly for signs of damage or deterioration. Damaged wiring or appliances can increase the risk of ground faults and electric shock. If any damage is detected, it should be repaired or replaced promptly. Electrical safety is a shared responsibility, and it requires the cooperation of homeowners, electrical contractors, and regulatory authorities. By understanding the requirements of the NEC and following safe electrical practices, we can create safer environments for ourselves and our families. The practical application of NEC Section 406.3c4 regarding GFCI protection near sinks often raises questions among homeowners and even some contractors. One common question is whether the 6-foot rule applies to islands or peninsulas in kitchens. The answer is yes, the 6-foot rule applies to any sink, regardless of its location. If a receptacle is located within 6 feet of the outside edge of a sink on an island or peninsula, it must be GFCI protected. Another common question is whether the 6-foot rule applies to receptacles that are located behind appliances, such as dishwashers or refrigerators. The answer is also yes, the 6-foot rule applies regardless of whether the receptacle is accessible or visible. If a receptacle is located within 6 feet of a sink, it must be GFCI protected, even if it is hidden behind an appliance. A further point of confusion arises when dealing with multi-gang boxes that contain both GFCI protected and non-GFCI protected receptacles. In such cases, it is important to ensure that the wiring is properly separated and that the non-GFCI protected receptacles are not inadvertently affected by the GFCI protection. One way to achieve this is to use a barrier or divider within the multi-gang box to physically separate the GFCI protected and non-GFCI protected wiring. Another approach is to use a dual-function GFCI receptacle that provides both GFCI protection and standard receptacle functionality in a single device. These devices are designed to prevent cross-wiring and ensure that only the intended receptacles are GFCI protected. It is also crucial to consider the specific requirements for wiring methods and grounding when installing GFCI protection. The NEC specifies the types of wiring methods that are permitted to be used with GFCI protection and the methods for grounding GFCI devices. Improper wiring or grounding can compromise the effectiveness of GFCI protection and increase the risk of electric shock. When working with older wiring systems, it is important to be aware of the potential for existing wiring to be incompatible with GFCI protection. In some cases, it may be necessary to upgrade the wiring system to ensure that it meets current NEC requirements. For example, older wiring systems may not have a dedicated grounding conductor, which is required for GFCI protection to function properly. In such cases, it may be necessary to run a new grounding conductor to the receptacle location or to use a GFCI receptacle with a self-grounding feature. It is also important to be aware of the potential for existing wiring to be damaged or deteriorated. Damaged wiring can create ground faults and increase the risk of electric shock. Before installing GFCI protection, it is essential to inspect the wiring thoroughly and to repair or replace any damaged sections. In addition to the technical aspects of GFCI protection, it is also important to consider the human factors. GFCI protection is not a substitute for safe electrical practices. It is still important to avoid contact with live wires, to use caution when working with water near electrical appliances, and to follow all safety instructions provided by manufacturers. It is also important to educate family members and others about the importance of GFCI protection and how to test and reset GFCI devices. By promoting electrical safety awareness, we can help to prevent electrical accidents and injuries. The ultimate goal of NEC Section 406.3C4 and other electrical safety regulations is to protect people from harm. By understanding the requirements of the NEC, following safe electrical practices, and promoting electrical safety awareness, we can create safer environments for ourselves and our communities.